Boarding a non-emergency medical transportation vehicle requires a very precise integration of machinery, vehicle physics, and human safety. A single point of failure in this chain can compromise the entire system. Professional transport relies on strict go, no-go safety thresholds. These are specific conditions that dictate whether a trip can proceed or if it must be immediately aborted before the passenger approaches the van. The first threshold is the baseline physical inspection. The driver must visually verify the structural integrity of the lift mechanism, the mechanical barriers, the interior securement tracks, and the vehicle floor. A damaged hydraulic line or a bridge plate that refuses to latch are clear mechanical failures. Environmental factors are equally restrictive. Deploying a lift onto an uneven slope, into active traffic, or over a steep curb forces an immediate halt to the loading process. Structural safety is decided during this initial sweep. Bypassing the baseline inspection means the rest of the journey begins on a compromised foundation. Once the hardware passes inspection, the driver begins the Ask, Explain, Confirm communication protocol. Before touching any mobility equipment, the driver secures active consent by confirming how the passenger prefers to be assisted and which way they prefer to face on the lift. This diagram shows the physical compatibility threshold. Drivers verify the specific dimensions and combined weight of manual chairs, heavy power chairs, or mobility scooters against the boundaries and weight limits of the lift platform. Verifying these details before loading prevents the need for dangerous, improvised adjustments while the passenger is suspended on the lift. Loading the platform requires a specific sequence. Center the wheelchair within the marked boundaries, engage manual brakes or kill the power, and confirm all outer roll stops are locked. This warning illustration highlights the mechanical pinch points and question zones active during lift operation. Dangling medical tubing, loose clothing, or unsecured bags can become entangled in these moving steel parts if they cross the platform boundaries. As the platform ascends, the driver's focus remains on the passenger rather than the controls, monitoring for any sudden shifts in stability. This deliberate operation manages the transition from the ground to the vehicle floor, maintaining a controlled environment during the most vulnerable part of the loading process. Inside, safety requires the WTRS dual system. A blue floor network secures the chair. A yellow network protects the human. 4 tension straps lock the chair's corners to crash-tested WC19 chassis notes. Attaching straps to wheels or footrests guarantees structural failure. The driver must tighten the straps to remove all slack, holding the chair immovable without applying enough force to bend the device's frame. Securing these 4 points creates a stationary seat, but the passenger sitting in that seat requires a separate form of protection. The occupant restraint system requires precise anatomical placement. The lap belt must rest low across the pelvic bones, and the shoulder belt must cross the center of the chest. This X-ray comparison reveals the hazard of routing a seat belt over a wheelchair armrest. This creates a gap that prevents the belt from making contact with the body, which can cause the belt to apply force directly to the soft tissue of the abdomen during a collision. While many wheelchairs have built-in postural belts, these are designed to help the user maintain their seating position. They are not structural components and cannot serve as high-velocity crash restraints. Treating the passenger's body as a separate mass from the wheelchair allows the occupant restraint to manage collision forces independently of the chair's weight. Before moving the vehicle, the driver performs a final visual sweep. All 4 tie-downs must be locked, belts must be flat without twists, and all auxiliary medical gear must be secured. If any component is twisted or loose, the vehicle remains in park. The driver must resolve the issue before the trip can begin. Smooth braking and gentle turns during transport help maintain the integrity of the tension securements and keep the passenger stable. This final verification ensures the system is ready for the road, moving the focus from mechanical preparation to safe vehicle operation. Unloading requires the same sequence in reverse. The driver must park on a firm, level surface away from traffic before releasing any restraints or securements. The driver releases the belts, maintains physical control of the chair on the lift, and monitors the descent until the passenger reaches the ground and is moved to their designated endpoint. Following these deliberate steps from pickup to handoff ensures that both the equipment and the passenger are protected throughout the entire journey.